Good afternoon. Today, lesson 7, we're going to talk about the law of cosines. In essence, what it is designed to do is to solve oblique triangles. So, what is an oblique triangle? Well, it's a triangle that doesn't have any right angles. Not only does it work for oblique triangles, it also works in right triangles as well. So it's kind of like the law of sines in that respect, in that if you have a right angle, you can use SOHCAHTOA, you can use Pythagorean theorem, you can sometimes use a special right triangles, but if you don't have right triangles, that's where law of sines and then today the law of cosines are going to come into play. So law of cosines comes in two different forms. First is what's called the general or the standard form. It's these three formulas below. A squared equals b squared plus c squared minus 2bc times cosine A. B squared is a squared plus c squared minus 2ac cosine b, and c squared is a squared plus b squared minus 2ab cosine c. It's designed to be used in triangles where you have like an angle B, across from it is side B, angle A across is side A, angle C across from it is side C. It works whether it's a right triangle or not. Now, as far as memorizing these formulas, it's really quite easy. You'll notice how if it starts with side A squared here, it ends with cosine A. B squared begins with, ends with cosine B. Starts with C squared, ends with cosine of C. And all the other stuff in the middle are the other sides that are not A, that aren't B, and in this case are not C. So this is designed to find side lengths. So what if I want to solve for the angles? Is there a different formula? Well, yes and no. It's called the alternate form, and what it's designed to do is to find the measure of angles, but it's not a new formula. It's just based on manipulation of the functions or the equations that we already have. Let me show you where it comes from. So I'm going to start with the very first of the general form or the standard forms. A squared is b squared plus c squared minus 2bc cosine A. And our goal here is I want to isolate the cosine of A and then finally angle A. So what I do first is, well, this positive b squared and this positive c squared that are on the right side of the equal sign with the angle A, they got to go. How do I get rid of a b squared and a c squared that are being added? Well, I subtract them. So minus b squared minus c squared, giving me something like this. A very common mistake that happens, people see this minus 2bc and they say, oh, let's add 2bc. Bad idea, because it is being multiplied. Addition will not cancel multiplication, division will. So I need to divide both sides by negative 2bc. Now you see I've isolated cosine A, but I want to clean it up just a little bit. Again, I'm not crazy about having this negative on the bottom. When you're putting stuff in your calculator, it can cause you some headaches. So I'm going to basically divide the top and the bottom by -1, or multiply top and bottom by -1, if you will. Basically, all it's going to do is change the signs. So the a squared will change from positive to negative, the b squared from negative to positive, the c squared likewise, and then here. And that's going to equal your cosine of A, and then, so this is going to turn into b squared plus c squared minus a squared. All I did was just a little commutative property. I just moved the negative a squared to the end. So I get b squared plus c squared minus a squared over 2bc is cosine A. So then if I wanted to, if I take this formula, how would I solve for angle A? Well, quite simply, I will just take and go with the inverse cosine of that. So that's how I can take the original or the general form or the standard form of the law of cosines and turn it into a form that solves for the angles. So here are basically the three what are called alternate forms, or forms that you can use to solve the angles. Now, when do we use this? Well, there's two cases that work very, very nicely. If you're given all three sides of a triangle, law of cosines is the bomb. If you're given two sides and the angle in between, likewise, it also works really well. I'm going to save the examples for another video, but there is one thing I do want to show you. It's something I put together. It's on solving triangles. We've had all sorts of stuff that we've done. So it's a little flow chart that I got. I will attach this in on my webpage so you can have the form of it. But basically, if you're solving triangles, it basically the questions you need to ask yourself first. Is it a right triangle? Is it not? Well, if it is, I ask myself, is it a special right triangle? You know, special right triangle being the 30, 60, 90, the 45, 45, 90. If the answer to that is yes, if it's a right triangle and it's one of our specials, then I just use the ratios that we had before. N, 2n, n root 3, and if it's a 45, 45, 90, n, and n root 2. Well, what if it's a right triangle? It's yes here, but it's not one of the specials. That's when SOHCAHTOA or the Pythagorean theorem comes into play. So to answer the other question, if it's a right triangle, what if the answer is not yes? What if it's no? That's where I can use law of sines or law of cosines. If I'm given that side-side angle or that angle-side angle, two angles with the side in the middle, law of sines, which is sine A over A equals sine B over B equals sine C over C, is awesome. Or like we just got done talking about, if I know all three sides, or if I have not two angles and the side in between, but two sides and an angle in between, your law of cosines works exceptionally well. So again, I will post this little flow chart there, so as you're doing your homework, it'll kind of help you out. The homework that I'm going to give you for this lesson is a mix of, you know, law of sines, law of cosines, solving triangles, and all that jazz. So I hope this helps. I will do a video on the examples, giving you some practice problems here. I'll post that as well. Thank you.